There's a handful of different projects that we're working on right now. We are studying a phenomenon called shockwave boundary layer interactions, and basically anytime you have a vehicle that's moving at supersonic speed, it generates shockwaves from anything that basically sticks out into the air. And there's some examples throughout history with the X-15 program where a stray shockwave boundary layer interaction actually ripped a hole in a vehicle. So that's something you don't want when you're not expecting it, when you haven't planned for it. So we have projects where we're studying those shock interactions, and we've got students making measurements related to those shock waves. And that's been very enlightening. We also have a project where we are studying what happens when you try and separate two objects that are moving at very high speed. You may be seeing videos of, say, space shuttle, solid rocket boosters dropping off. Imagine if you're doing that in a very high speed environment in the atmosphere. That gets really complicated, and it's tough to predict with the computational models that we have right now. And then we have another really neat project that we're doing with NASA and UT Austin and the Air Force, where if you imagine you took a vehicle that you wanted to test in flight, like a full-scale vehicle, you're going to be limited to the number of sensors that you can place to measure how that vehicle is performing. We had this idea where what if you could use machine learning and artificial intelligence to basically fill in the dots between those different sensors and actually learn a lot more than what you actually got just from the sensors themselves.